Okay, here's a video on linear inequalities. So let's look at some equations here. We have the top equation is a linear equation, has the equal sign. But when you see these greater than or less than signs, that's an inequality. So you can see signs like this, signs like that, signs like that, and signs like that. Okay, these are the signs that you can see. Okay. In this case here, we're saying that y is less than 3x plus 6. So when we have an equation, let's get a new marker here. So we're saying, with a linear equation, we're saying y equals mx plus b. And b is the y-intercept. That's where the line will cross, the y-intercept. And m is the slope. So in this case, we have y is less than 3x plus 6. So 3 is the slope, and it crosses at 6 on a graph. Let's look at this question. So here we have a domain and range box. The x is the domain and the y is the range. So we can plug in. Here we're saying that y is greater than 5x minus 9. So we can plug in anything. We put in as 0 for x. So 5 times 0 is 0. 0 minus 9 is negative 9. And so forth. We can put a 1 for x. 5 times 1 is 5. And 5 minus 9 is negative 4. And so forth. I'll do one more. So 5 times 2 is 10. And 10 minus 9 is 1. So that's the same way we would do a linear equation. So let's look at an inequality on a graph. The shaded area is the solution. This is the solution right here. Now when you see you could either see a dotted line or a solid line. So when you see a solid line, that means you're either going to see this or this inequality. This means that y could be included on the line. So y could be less than or greater, or y could be greater than, y could be equal or less, or here y could be greater or less. So remember, if it's a solid line, you're using these inequality signs because you can include the solution on the line. But if you see a dotted line, you'll use these inequality signs. Remember that. So let's look at the equation again. So let's try to make this equation. First of all, take any point on the red line and go up. So if you take any point, look, here's a point, and you go up. Here's a point, you're going up. Here's a point, you're going up. If you go up and you're in the shaded area, then this solution is above the line. And just by looking at this graph, you can see the solution is above the line. When the solution is above the line, this is important, when the solution is above the line, you're going to see y is going to be greater, or, depending if it's a dotted line or a dashed line, in this case it's a solid line, so y is going to be greater or equal to, and it's going to be mx plus b. Bring it there. So again, if the solution is above, y is greater. If the solution is below, y is less. One more time. The solution, we went up on the line, and here's the solution, the shaded area. That means y is going to be greater. And it's greater or equal to because it's a solid line. Alright, so again, if this was, let's say we had an equation here, and here was the line. Well, let's do it again. Let's say we had a dotted line, and the solution was here, let's say. This is the solution. So if you go up on any point on this dotted line, it's not in the solution. So the solution is below the line. Since the solution is below the line, and since it's a dotted line, y is going to be less than mx plus b. Bring that over. Okay, so again, if it was a solid line and the solution was here, y would be less than or equal to mx plus b. Since it's a dotted line, y is less than only mx plus b. Okay. So let's take this again here. From this graph, we can see the solution is above the line. The solution's above the line. Right? So we're saying, and it's a solid line, so y is going to be greater or equal to mx plus b. Now we're trying to find what m is and b. So we can look, let's look at the graph here. You can see it's right on the 1. So we know what b is already. So here we'll write it up. It's y is greater or equal to mx plus 1 because it's on the 1. Let's look at it again. Right there, it's on the 1. We know that this is going down from left to right, so we know also that m is negative. So now we need to find the slope. So let's look at this graph. You can find the slope a couple of ways. If you go down 2 and over 2, let's see if it happens again. Down 2, over 2, down 2, over 2. It looks like you're going down 2, over 2 each time. So what would that mean? So the rise over run, the rise is the y, over the run, or sometimes you see it as the change of y over the change of x. Right? It's down 2, over 2. So let's circle this for a minute and then we'll go over it. Let's look at also some points on this line. We have a 0, 1, that's 1 point. We'll put it up here. 0 is x and y is 1. That's 1 point. And let's look at another point. We have 1, 0. Right? So you can take that, let's erase this. You can say the change of the rise over the run, this is how we get the slope. We're saying we can take, and here's the points. We have a 1 and a 0, so we can say 1 minus 0 over 0 minus 1. And you get 1 over negative 1. So the slope is negative 1, which you knew by just doing this before. So now we know our equation. We'll bring it here. Y is greater or less than negative 1x plus 1. In fact, you don't even need the negative 1. You can just say y is greater or equal to negative x plus 1. That's the solution. Okay? Let me just go over this again with solid and dashed lines. If you see a solid line, you're going to use the inequality of greater or equal to, like we did here. And the reason why we're using y is greater is because the solution's above the line. If the solution was below the line, y would be less than. So let's look at this one, this graph. Is this true or false? Circle this. Would this be true or false? It is a solid line, but remember, look at the solution. The solution's below the line. Since the solution's below the line, y can't be greater. So since it's below the line, y has to be less than or equal to mx plus b. And again, we're saying or equal because it's a solid line. So see if you can do this one now. Bring this down. What would this be?